deciding to go for one more. Now, I'm not going to state too much of the things I stated before. Hopefully, we feel comfortable with that already. It says sketch v of x equals sine of 2 times x minus pi over 3, and then w of x, which is cosine of 1/2 times x plus pi over 2. Find the period, find the interval value, the starting value, and the remaining grid value. State the amplitude of the function. Well, the period. To find the period, it is 2 pi divided by k. And I'm looking at the first function, which is v of x, equals to sine of 2x minus pi over 3. In this case, the k is 2. So that's going to be 2 pi over 2, which equals to pi. So to find the interval value, which I'm going to call IV moving forward, in this case, although IV means independent variable, that is going to be 1/2 times my period. I keep saying 1/2. It is 1/4 times the period. 1/4 times pi equals pi over 4. The starting value in this case is going to be pi over 3. Now remember, we are subtracting pi over 3 from the variable. When we are subtracting from the variable, that is a horizontal shift to the right of pi over 3 units. Now we want to find the remaining grid values. The first value is pi over 3. To find the second one, we're going to add the interval value of pi over 4. When you multiply, so when you add fractions, you must have the same denominator. So we're going to multiply each denominator until they're the same. The least common denominator in this case is 12. So multiply the first fraction denominator by 4. Do the same thing to the top. The second one you'll multiply by 3. And then do the same thing to the top as well. So that's going to be 4 pi over 12 plus 3 pi over 12 and that's going to equal to 7 pi over 12. And that is the second grid value. And let me label pi over 3 as the first one. Now, to find the remaining, we're going to add 3 pi over 12 to the second grid value. We get 10 pi over 12. And we can reduce 10 pi over 12 to 5 pi over 6. Add another 3 pi over 12. That is going to be 13 pi over 12. Add one more 3 pi over 12. That's going to equal to 16 pi over 12. Which reduces to 4 pi over 3. Let's add the next ones. Last but not least, the amplitude. There is no number being multiplied in front of your sine function. So the amplitude is 1. The highest value is going to attain is positive 1. The lowest value the function will obtain is negative 1. And this is a sine function. Remember the pattern. 0, max, 0, min, 0. Oops. Now, if you're wondering, is this the same one from part A when I did it? It is not, because the grid values are different. Look here. These are my grid values for part A. The function goes from pi over 3 to 7 pi over 3. The reason why is because the period was 2 pi. But in this one, this function goes from pi over 3 to 4 pi over 3 because the period is pi. Different period, different grid values. So let's move on to the next one. And that is w of x equals to 1/2, no, rather cosine, cosine of 1/2 x plus pi over 2. Now, to find the period in this case, it is 2 pi divided by the value of k. That value right there is going to be your k. So 2 pi divided by 1/2. You're going to use keep, change, flip. So that becomes 2 pi times 2, which is 4 pi. So it'll take 4 pi revolution for my function to go around one complete time. To find your interval value, that is 1/4 times your period. So 1/4 times 2 pi, well, times 4 pi, excuse me, because that's the period. That's going to be 4 pi over 4, which is just going to be pi, because the 4's simplify each other out. So every interval will increase by pi units. The starting value, and that's based on the horizontal shift. Because the function, because there's a value being added to the variable of x, because we're adding pi over 2 to the variable of x, we're going to shift the function pi over 2 units to the left. And when I shifted pi over 2 units to the left, we're going to start at negative pi over 2. And that's the first grid value. Now let's apply the periods. We're going to add pi. Whenever you are adding with fractions, they must have the same denominator. So we're going to make that pi as pi over 1 and find the LCD, which in this case is going to be 2. The first fraction is fine. The second fraction needs a 2 down there. So we're going to multiply 2 to the bottom and then 2 to the top. So that's going to be negative pi over 2 plus 2 pi over 2. This is my first grid value. And that's going to equal to positive pi over 2. Then repeat the process. Add 2 pi over 2 again. Equals 3 pi over 2. That cannot be reduced. Repeat the process again by adding another 2 pi over 2. 5 pi over 2. And then you're going to add another 2 pi over 2. And that's going to be 7 pi over 2. Let's place those grid values on the number line. So it's going to be pi over 2. 3 pi over 2. And make sure I'm doing this correctly. Maybe we should have enough room on this grid here. All right, I had to kind of shrink everything down so I could be able to fit all the grid values or the grid points onto this coordinate plane. And remember, the amplitude, there is no value that's visible being multiplied in front of the function. So the amplitude is going to be 1. So the highest value this function will attain is 1. The lowest it will obtain is -1. And remember, this is a cosine function. When it comes to cosine function, at the starting value, it is at its maximum. Then 0. Then minimum. Then 0. Then back at the maximum. And this is how your function will look when you sketch it. All right, guys, that is it for this video. Hope you enjoyed it. Hope you understood it. Hope it makes more sense now. Now, for the next part, C, D, right? Well, C and D. I'm going to skip a little bit of steps when it comes to finding the amplitude. Well, no, when it comes to finding the period and stuff like that. Hopefully, we have a good understanding on how to do that. I'll see you soon, guys. Take care.